Good morning, Integrated 1 students. So today we are looking at tessellations, which is a long word, but the concept is right in front of you on the screen that I'm sharing. So this is the assignment 123 document. Number 1 here, you can see that there are equilateral triangles in different colors, and they're arranged in a pattern. So they all interlock with each other perfectly. They don't leave any space between each other, and that pattern can be repeated. So this is called a tessellation, when you have shapes that interlock with each other, the same exact shape over and over and over, without leaving any space in between. So on the left here, we have some equilateral triangles that do that. And on the right, we have some squares. Both of these are regular polygons. So the first question says, could we slide the above patterns indefinitely to cover the entire plane? What that means is, can we take those shapes, like can we take that chunk of equilateral triangles and slide it in a certain direction and leave it there, like lock it in place, to create more of that pattern and have the pattern look exactly the same? And if so, can we keep doing that over and over and over to cover a space of infinite size or any larger space? Same with the checkerboard pattern. Could we take that pattern and shift it over a certain direction and have the pattern look exactly the same, except covering a bigger space? So that's the first question here. The second question says, do these patterns have reflection symmetry? Reflection symmetry, as a review from last week, is can you draw a line straight through one of these figures in a certain direction that would let you fold, like if these shapes were on a piece of paper, you could fold the shape in half using that line as the crease in your paper. And if you did that, would the shape line up perfectly with the other side? Like, would it fold over and line up perfectly with the shape that it lands on top of? It's another way of asking, like, is a shape like a mirror image of itself? If you mirrored it, or do both sides look exactly the same on either side of a line? So that's reflection symmetry. And then rotational symmetry, which is that third question, is asking, can we rotate these shapes? So like, can we rotate it a certain number of degrees and have it look exactly the same without rotating it all the way around? Like, obviously, if we spin it 360 degrees all the way around, it'll look exactly like it did before. That's not what this is asking. It's asking, can we partially rotate it, but have it look exactly the same? So next, we're going to be using GeoGebra to make some tessellations. So I'm going to show you how to do that. When you go to geogebra.org/geometry, this is what your page will look like. You need to click on the More button. And then the first tessellation we're going to do is with a triangle. So you can click the polygon button right here, and then make a triangle. You click, click, and then click on your final point. So the way to create a tessellation in GeoGebra is by using the midpoint tool and the reflection about point tool. So I'll show you how to do that. Click midpoint or center right here under construct. And then you want to click between 2 points and it'll make a midpoint. So it just added a midpoint to that side of this triangle. Then I'll click A and C to do the same thing. And then I'll click B and C to do the same thing. Now I have 3 midpoints on my triangle. And I can scroll down to the bottom here, click the reflect about point button tool. Then I click my triangle and I click one of those midpoints. And then I click my triangle and I click another midpoint. And I click my triangle and I click the third midpoint. And now it's made copies of that shape in such a way that they interlock with each other. And then you can do the same thing to make your tessellation even bigger. So I can do that for these outside points. And once I do this, it's going to make my pattern even bigger. Now I go to reflect about point. I click my shape. I click the point. Click my shape. Click the point. Click my shape. Click the point. So this is what you're going to need to do when you're answering questions about exploring whether a shape can tessellate. This is what we're asking. Can you take a shape and rotate it or reflect it and make it so that those shapes interlock across the plane to cover a bunch of space just like this.